All right. Hello. Welcome to the first installment in this here little doodad. That is me attempting to translate the BEPU. That's what I'm going to call it. It could be BEPU. I don't know. Physics system, which is written in C# and agnostic of any sort of engines that you'd be using it with. And I'm going to tightly couple it with the Unity engine, and specifically their new entity component systems, ECS system, and the job system. So I've done a little bit of work already. I don't expect to be doing all of these, all of my coding while I'm streaming. I'm going to try to do some of it there and some even now. But I did some work beforehand, so I want to kind of bring you up to speed on what I have done. So if you don't know, what the entity component system and the job system for Unity are, I'd recommend going and actually watching some other videos, reading up on the documentation on that. I'm not going to go over all of that stuff because that's quite a lot of stuff. Oh, I should have known that. Ha 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 ha. And so I'm gonna put this be right back up already because I need to go take my medicine. Okay, sorry about that. So I can't imagine this is going to be like the most popular thing that anyone has ever watched or incredibly entertaining or whatnot, but I hope that through it you might learn something, and I'm certainly going to be learning things because this system is very new and there's a lot I still don't know about it. So with that being said, BEPU Physics is, like I said, a C# system that you can find here on GitHub / here we go, BEPU Physics 1. It's a C# system agnostic to whatever engine you want to use it with. And this is the sort of tried and true tested version that's been around for a while. There's a new library that is supposed to be faster, but it uses some things from C# 7, and Unity is almost ready for C# 7, but it's not. So there would be so much work in even trying to translate that part alone that I decided to go with the version 1, also because it's more stable. So this is a little job that I'm giving myself since I've recently been laid off, and I'm looking for stuff to do, and this is one of those things. So let me go over a brief overview of what I've done. So the BEPU physics system uses this thing called a space, which is kind of like the Unity entity component system world. And the space needs to have an update called every frame, or as often as you want to update it, I suppose. You can optionally pass in, you can optionally pass in here a delta time here's the update with no delta time, just as one time step, and here's the update with delta time, which it's only going to actually calculate a time step if actually you want to do a time step via the time step duration and the time step duration. So if only enough time has passed since the last time you did a time step, then it'll do one. So if you have like a super fast frame, you might not do a physics update just yet. But it's going to go in here and it's going to try to update your interpolated states so that in between the big physics updates where it's doing like all the work and all the calculations, it's going to do some interpolations to try to make the state of the objects still seem more realistic than not moving at all. And so basically what my goal is with this, at least like round one goal is to take all of this stuff here and do time step and put it in the entity component system and the job system, because I think if these things can be jobified, then we can get some really big performance increases. Also, Unity is yet to release their own physics system in the entity component and job systems. I'm sure they are working their butts off to do that, but it isn't out yet. And I doubt that like I'm going to be able to create a more efficient system or even a closely efficient system in this time before they come out with theirs. But it's just an interesting sort of endeavor, project, experiment to try to learn some things. I'm also curious to see what kind of benchmarks it's going to be versus both the single-threaded and the multi-threaded using their old, or the system that BEPU comes with, which is called the parallel looper, which just creates threads, worker threads, and calls loops on those, but it doesn't do any of the sort of like memory optimizations that Unity is really strictly enforcing here with its or is trying to get you to enforce and to do with its job and entity component systems. So I'm going to be trying to rewrite these in such a way that it respects those. I don't even know how long this is going to take. It's probably a much bigger project than I even imagine it to be right now. So I certainly don't understand the BEPU physics system as is even right now. There's a lot of things that I've never touched, I've never looked at, like 99% of it probably. But I'm just going to go one thing at a time kind of and see if we can get down this list and port what we need and want over to the new system. The other cool thing about this is that even though we'll be tightly coupling it with Unity, which is kind of necessary because of their job and other systems and how they work, is that I'm going to ditch their sort of like entity system in the BEPU world, and we are going to be using Unity's entities. So actually I'm going to be using the provided position and rotation components so that those things will be directly updated. We won't have to worry about like reading after the physics system is updated, like reading our values back so that we can be like, oh yeah, now the value is right. Like it should be updating with with the actual entity, and some of the systems that Unity has already written for transforms. And so with that, like, it'd be as if this physics system is really directly built into Unity itself, instead of just sort of pumping values into it and getting values out of it and then applying them as a whole separate step. It's like all in one step right now. There's only one place where the position is stored for the entity, and this physics system will be writing to that position. There won't be any intermediaries, so that's exciting. All right, enough sort of overview and introduction. What I want to do now is sort of talk about what I've already done, and then we'll get into something that a sort of optimization of the one thing I've already done, because I'm realizing that it should be in a different way. So the first thing here on this do time step method or function in the space class of BEPU physics is this space object buffer, and it's got this update method. So space object buffer is an instance of the class space object buffer. So if we go to space object buffer, going to close a couple of these things here. All right, space object buffer here. What it's doing is it's got this little struct. Actually, I might have changed this into a struct. I can't remember. It's got this little class or struct, one of these two. The space object change. And it takes an iSpace object, which, if we peek into that, is just, it's got a tag, which has some data, some just generic data, because it's just an object. It's got some methods that are called when it's added to a space and when it's removed to a space, and then it's got the space to which it belongs. So, and then it's got this Boolean, whether or not you should add it. And then we have this concurrent DQ, which is basically like a thread safe queue. So when you call add and you add a space object, you create a new space object change with that space object, and true. When you call remove, you pass that object in and call false. And its update stage, it tries to DQ, and if it should add, it tells the space to add it, and if it should remove it, it tells the space to remove it. Well, trying to map this onto Unity's entity component system is interesting. There is there's no real one-to-one map here, I don't think. Because basically you're just going to have these systems that are interested in things when they have a certain set of components, component data attached to these entities. So what I've decided is that, at least for right now, until I can find a reason, I'm going to ditch the space altogether. And the space doesn't need to add anything. It doesn't need to remove anything. We might still have to do some of these like physics things here that does raycasts and such. We'll have to figure out how those go, but for right now, there's those two other things, add and remove, and it's got update. And that's about it. So basically what it does on the add anyways is it tries to cast this one thing as like all of the sort of base types that all of these different managers could be are interested in. And that's sort of a very sort of object-oriented way to do that. But I can't imagine that this is that optimized either, because you're just going through here and casting and casting and casting and casting and null checking and null checking and null checking. And then here at the end, you tell it that it's been added to a space. I'll have to check what exactly that does, if there's anything, and we'll have to sort of implement that in some way if it does something that's really important that I don't know right now. But for now, I'm not worrying about that. I'm just gonna try to get the really basic stuff happening. So basically, all this space object buffer does is it takes everything that's asked to be added or removed, and it's going to try to it's going to tell the space to add or remove them. So honestly, I think it's a little bit of an oversight right here that the space object buffer is part of this do time step. I really think that it should be outside of it. It's a completely useless call when you are down here in the multi-threaded update, or not the multi-threaded update, but when you're down here with the delta time update, and if you are processing multiple time steps in a single update, then like you're telling the space object buffer to update, and it's going over here, and it's like, okay, so I'm going to update, and then it tries to DQ that. Nothing will be there because you already did it last time, and then it'll exit out. But like, why this extra computation? Doesn't seem to be necessary. It seems like you could throw that outside of the time step and it'd be fine. We already have stuff out of the side of the time step as it is. We have this end of frame updatables update, and down here we have interpolated states. So we could have like a pre-time step thing. That doesn't seem unnecessary at all. Which actually, now that we're speaking about it, that is exactly the thing that I am going to do live coding on here. And so for that, let's get to what I've added. We're going to ignore the space object buffer. We're going to ignore the space now. Excuse me. So now we're looking at the one physics system, or job component system that I've created. The only system in the new Unity entity component system sort of idea and solution that I've actually created. So this one is a job component system. That means that it runs jobs, and it's optimized to run jobs so that they don't have to be completed on update, and you also get the dependencies for any jobs that would be dependent upon that the compiler finds out or assumes are dependent. So right now I've got the space membership barrier. I'll go over that in a bit. I've got this membership debug group. Yeah. I've got some things up here. I'm not using the time step settings yet. I guess that'll be a good next step. Maybe we could even try to do that in this stream. And I've got this. One thing that is important here is I've got this membership request changes. And right now it is a dictionary of entity to byte. I'll tell you exactly why it's byte in a minute, but basically, I'm going to make sure that's initialized when we create the manager. I just kind of want to have this method overridden here so that we have something, and so that if I need some other initialization, it can go up there. On add, I'm going to try to add a request with the entity in true. On remove, I'm going to try to add it with entity and false. There's a bad bug here. I mean, honestly, this add also doesn't really know yet. This is one thing I have to think about in the future. I'm queuing up all of these things, but I don't know. I have no way to know if they already have a component on them or not. And that's really important because it's going to throw an exception if I try to add or remove a component that doesn't exist or already existed. So right now, I'm doing this silly conversion from Boolean to byte. Again, I'll explain that in a second. But I'm just trying to get out the entity, and if we've already requested the thing and it just hasn't been processed yet, then we're going to return. That's the if request equals desired. Otherwise, basically whatever we requested is going to cancel out the other one. So if we first requested a remove and then we requested an add, I can't see any current reason to do that, especially because the only thing that we're adding is a single shared component with no data in it at all. It's just a marker to process it in the system. So we're just going to remove it from the dictionary itself. Otherwise, we're going to add it here with the entity and the desired action. So I guess I should have explained what is exactly going on here first. The one thing that is definitely going on right here is we are scheduling space membership changes, which I thought I was going to still model the whole space idea. It's a good word, I suppose, as something to talk about where the physics happen or the idea, the abstract world in which they happen. So you either get added to that world or you get removed from that world, and the only word that I could think of was membership for that. So we're trying to either add or remove this one component here, and it's so simple. It's just, here we go, simply a marker that the physics system should process this entity. Ours, our BEPU physics system here that we're implementing in Unity, and I'm gonna all the stuff I'm gonna make, I'm gonna put under Unity.BEPU physics, which Unity is never gonna make that namespace, so it's fine. And now I won't conflict with the BEPU physics namespace. So this here down here is why I originally had this byte in the dictionary. It's not necessary now, but basically I was creating a job to process the space membership, passing in the command buffer that I'm creating with this barrier, and I was changing the entities into a native array of entities and the bytes into a native array of bytes. And you can't have a native array of Booleans because they're not blittable, which I found out today. But bytes are, and they're small, and I only need a really, really small thing. The weirdness about this was you can't do an iJob parallel for, so you can't run these in parallel. So I wasn't getting the performance from that, and then I was having to do this like .to array, which is like a link, extension on these keys and values, and so really, I'm not getting a performance boost out of this job. It was actually the most expensive thing. I mean, at a measly 5 milliseconds, but it was that. that was the most expensive thing that was happening. I decided to take that out because I could just put it in a command buffer in this job, or in this job component system itself, and that would be enough. And that actually, it pretty much eliminated the cost of that. It's nothing now. And then here, so I'm scheduling these space membership changes. So I'm only running if our count's greater than 0. I create a command buffer from the space membership barrier, which is a barrier system that I've injected. I loop through my request changes. If the value is 1, then I add this shared component, this BEPU physics object, with the request key, which is the entity. So to this entity, I'm adding this component. It's just an empty shared component data. It's shared because there is no data. There never will be any data. And so there's 0, you can add it to as many entities as you want, and there's 0 cost in the memory for that. It's just a pointer to that, 1 data, which is super cool. Then here, if the value is not 1, I'm going to remove that component on this entity, which is the request key. After all of these are processed, I'm going to clear out the changes, and that's basically the one thing that's really happening right now. The other thing that's happening is I'm just debugging all of the entities that are currently members of our interested parties. So I created this membership debug group, which just, if we go here, it's got a shared component data array of the BEPU physics object. Just means it should have this, and I've marked it as read-only because we don't need to do anything with it. We've got this entity array and the length. So here in the membership debug job, we've got an entity array again that's read-only, and we're just printing out the index and the version of the entities here in the entity array. So when I come down here in the onUpdate function, I am returning a new membership debug job. I'm setting the entity array equal to our membership debug group entity array, which I've injected up here. This is just something that Unity will fill up for you with all of the entities, or with from the entities that have the components that you ask for. And then I'm scheduling it with the length from that group, which you can inject for convenience. I'm splitting it up into chunks of 64, and I'm passing in the input dependencies. I'm returning this .schedule, which returns the job handle, which is what this update wants us to return. So what that looks like over here is, I hit play. I'm just going to get a bunch of numbers printing out here. Here we go. So we've got all these entities. And why that's happening is I've got one more, I forgot one more script here that we need to know, which is this physics test script. This gets our entity manager on awake with world.active.get or create manager, entity manager. It creates an entity. It adds a shared component data with a BEPU physics object. And then this is so that right now, this physics system, because it cares about that group, because I'm injecting that group, it's not going to run if nothing has a BEPU physics object component on it. Which is a problem if at the beginning of the game nothing has it on there, because even if you try to add it via the static methods, you're just going to add to this dictionary that will never be called on awake or on update, because on update is not called for job component systems or component systems whose groups that they care about are empty. We'll actually fix this, the need to do this here in this stream, I believe. So then here in the update, this is just for like something to do, just to populate this so that I can test that even this sort of this buffer, this reimagining of the space object buffer itself will actually work and do something that I want it to do, which is add them to the physics system or remove them from the physics system as entities that they should be concerned about. So I'm just getting a random value every update. If it's greater than 0.75, then we're going to create an entity. We're going to add it to our list of entities here, and then we're going to tell the physics system to add it. Otherwise, if it's less than 0.25, and then if our entities count is greater than 0, I guess I could have put this in an and here. I'm just going to fix that right now. There's nothing I want to do solely if that's also not true. Get rid of some. Cool. Then we're going to get a random index between 0 and the count. We're going to get the entity at that index, and we're going to call physics system remove that entity, and the entities remove at that index. So we're just kind of adding to and removing from this list and from the entities that the Unity is concerned about here. So if I hit play again, you can see that it's going to start out with the entity index of 0, only ever printing out, and then we've got these other numbers showing up. We're in like the 40s now, but there's still some old ones, and we can also view this information here, which is where like we can see how much time things are taking. Wow, I guess the space membership barrier is still taking like quite a bit of time. I didn't realize that the space membership barrier is still taking that much time. Maybe that job was actually more efficient than I thought it was. I'll have to figure that out. Right now it's looking like it's averaging 10 seconds. Although I am streaming right now, so I guess I'm not surprised that if that's kind of a little bit more of a burden on things. So the physics system here, these are the entities that it cares about. Entity 0 will always be there because I never added it to that list, so it never gets removed. So it always will run. And then here's some entities. They don't get to live very long because the randomness will eventually remove them. And the list never grows that long. I've got essentially equal-ish odds. Okay. So what I'm going to do now in this stream, because I actually wanted to do some live coding, is that I want to split off from this physics system, and we're going to create a new system, and it's not the deactivation system. I don't even know if I'm going to keep that. You won't have this because these are my script templates that I added, but you can make your own script templates. It's so good. It's the best. Do I want a job system or do I want a system? It seems like the job may have actually helped. I'm going to first use a system, and then I'm going to use a job system. I'm going to compare the two. I'll create two of them. So I'll call this the space membership system. And then I'll create also a space membership job system. Cool. You know, I really should change my script templates here so that they do the things they need to do. Okay, here's a job component system. Where's my space membership system? Is it yelling at me for something? It doesn't. Oh, wow. Okay, so on update is you have to. Okay, interesting. That's a difference between the two. Okay. So, so my thought here basically is the same idea around space. The space class that we looked at earlier, the space object buffer, didn't need to be part of the time step. Basically, everything in the physics system I want to be part of that do time step, so that it should be repeated if enough delta time has passed. Then we're going to try to do multiple physics time steps if we've lagged enough since the last frame rendered. So we're going to do basically this, except that because this is just a component system and not a gonna steal all these things, because this is a system and not a job system. Or I'm sorry, this is a component system and not a job component system. We get access to the post update buffer instead of having to use a barrier to create a command buffer. So I can get rid of that. Where's my on update? I'm going to take this back down here. Okay, so down here on update, I'm going to call schedule space membership changes, which this is the post. Ha! There it is. Post update commands. And this is in the BEPU physics components namespace. This actually should be namespaced in Unity BEPU physics. I haven't decided if I want systems to be in their own namespace, but okay. That looks pretty good. The one thing I want to do here is we're going to do update before the physics system, which this is going to, I need to do type of. But this is going to fix a problem that I have right now, which is that how do I get this to not run? I guess I can just, if I just comment this entire class out. Here we go. Before I really get there, I'm going to private int count. I'm going to log that we are adding entity at count. So this is going to be request key, which represents my entity here, and its index at count. At the end of our I'm going to have to hold this in a variable. All right. If our handle is that, return handle. And we're going to count ++. Cool. Here in the debug job, I'm going to need to add this. Make it read-only, public int, count. And I'll add count here. So now, do. I'll need to initialize that here. Count is count. We should see the difference between when we schedule an add and when it actually gets added. Just gonna let it run for just a few frames. Cool. So, wow, 72 frames already. So, okay, we're adding entity 1 at count 2. Here, we are printing count 2. We're printing all of our entities from this membership debug job. And we only have entity index 0. At count 3 here, we're adding entity 2. And at count 3 here, we have entities 0 and 1. Count 4, we have 0, 1, and 2. So it's taking 1 frame to get those in. 1 frame after we ask for it to be added, it becomes added. Now that we have this system, the space membership system, and we are asking for Unity to update it before the physics system is updated, I'm curious to see if it too will do the same thing, or because it actually gets updated first, whether or not it will actually add it to the space and add it to the entities that I desire to do stuff with in my other in my physics system here. By the time it actually gets to that physics system, oops. Copy this. Cool. And I'm going to go my physics system here. I'm going to oops. Comment this out. Which means commenting that out. I don't need this barrier system. I don't need to inject it. And I don't want these add or remove methods available. So my physics test is going to be really mad. That's okay. I've got something to replace it with. The space membership system. Okay. Theoretically, this space membership system is going to update before the physics system. The physics system doesn't have any update, anything. And then here when I get down to debugging all of these, I'm super curious if this will change at all. So I'm just going to let it play for like a second. I'm going to pause it this time so I can also take a look at the entity debugger. So we've got this space membership system. Whoa, okay. More importantly, I've got 999. The previously scheduled job, membership debug job, reads from the native array. Oh, I had this problem before. I'm going to start this count at -1. And just put this count up here. I'm just going to return. I don't think this is actually going to fix anything. But I did have this problem when I tried to update the barrier system before the well, I thought I had that on snooze, but that was a minute ago. Snooze. Okay. D. Okay. What am I doing here? Clear this crap. Is it going to give me a bunch of errors again? I'm going to guess yes. Oh, definitely. Reads from the native array, entity array. You must call job handle complete on the job membership debug job before you can deallocate the native array safely. Well, now I'm stuck. Now I don't really know what's going on. But because it should be flushing this. It should be flushing this system. It's post update buffer. When this on update's done. And then over here, it's got this array of entities that have this shared component data on them. Oh, I wonder if it's that. So this other job. Maybe the problem is that this other system is still a system and not a job system. I'm going to see what happens if I just comment all of this out for right now. Beep bop. Is it going to even? Let's see. Not all code pass return a value. Oh, right. I've got to return my input dependencies even if I do nothing. Or if I do nothing, I suppose. This isn't... Okay, so if I go over here to the entity debugger. Okay, so... That is Wow, that is absurdly fast. Compared to that barrier that we were using earlier, it's generally taking less than a millisecond. So that's a lot. That's a lot of optimization. I just wonder if there's a problem between updating a system before a job system if they're both touching the same entities. And if that's the thing that basically Unity is yelling at me about. Right now I have very many entities. Okay. I guess the real question is if I want to do something more interesting than simply debug them. I mean, I used to be able to do that. So I guess let's try really quick this space membership job system. We're going to essentially do almost everything that this was doing. Except that we need to... That on update is wrong. Oh, okay, yes. Haven't told them I'm using that yet. Alright, and I don't have post update command, so I need to make a command buffer, and I need to get that from this barrier here, which also doesn't exist yet. It's down here. And take this out of this. There we go. And we're doing this. There we go. And we are going to update this before the physics system. Oh. Ha. Didn't get the namespace in here. I thought I was getting that out of the... Not that I suppose it matters. Command buffer is space barrier. Create the command buffer. Barriers can magically create this command buffer thing. That's what they're there for. And then we use that command buffer to add components, remove components, create entities, delete entities. And I think also set component data. Or set shared component data, because that's like an expensive call. Which then we're going over here. Let's find out. We're going to have a problem because we're going to have two things that want to care about the same thing here. So we're going to copy, we're going to uncomment this. This barrier is told to update before the physics system. We are going to schedule the membership changes. And we're just going to return the input dependencies. So this is going to be almost exactly the same as last time, except it's going to have this barrier system that is creating our command buffer instead of this automatically created post update buffer. The problem is we'll need to go over here and Now we need one that is the job system. Copy this. This should fix that problem. And we should be on to All right. So there's our space membership barrier working as seamlessly fast as the last one. Seems to be really cooking. If then I come back here and I uncomment this again, what happens? I'm also really curious about why. Is it just like I had it in a different point in time using my computer and I somehow freed up some resources since then? Or I mean, that doesn't make any sense, but I just can't think of why that's like 10 times faster than it was just doing the same thing in a different system, because I'd use a barrier system again. My guess is I'm going to get all those errors all over again. Yeah. So I've got all these errors again. What I could do is I could bring back this space membership job and it's going to look a lot like this, but actually a little bit different. Oops. And I'm going to attempt to space membership job. I don't need to do these anymore, I don't think. Actually, I really don't know what's going to happen if I don't. If I don't do that. I think it's going to be really mad at me that I didn't dispose of those arrays. But I don't really know. I don't really know what to do then. Do you have to complete? Can you use like a job component system, like job component systems are meant to be used, which is that you just schedule the stuff and let it do its thing. And have native arrays in your job, because how are you going to dispose of them? Because complete is not called by you, so you don't know when to dispose it. If you like hand that over to the system, what happens? So now we're going to do return that overload of this method, which I think if I was going to do this could be optimized here, because this is an extension method from link, and that can't be fast, or faster than changing a list to array at least. But I just want to see if it actually will run now. and I don't know if it'll complain about the native containers and yada, yada, yada. Oh, boy. This is the one we're still hung up on? Membership debug job? Are you kidding? All right, you know what? We're going to go and we're going to comment this out again. And then we're going to uncomment this. And now we're just going to do an A/B between the job system or the job component system and the component system. And we're just going to see which one of those. And like I said, I can make those into lists instead of, or like queues. Well, hot damn. Oh. Wow. Okay. I just got a bunch of memory leaks. All right. It was allocated at 84. I figured that was going to happen. Why did it take so long? Yeah, here we allocated them. Which I think temp job should be fine, right? It's not been disposed. All right, so if I add these back in. These do the disposing for us. Shouldn't get any more errors anymore. I bet somehow it's gonna. Wow. I am really surprised that that is as quick as it is. I think that's even quicker than the system that I previously had. But I still don't understand why my membership debug system does not work. Here we are, we're just adding and getting rid of these things as fast as they go. Yeah, I mean, it doesn't even touch a second. I've not even seen it touch a second yet. So there's one. It looks like there is some performance to be gained just from the fact that we're not doing it on the main thread. We're still scheduling a job somewhere. Even if it's a parallel job. So that's interesting to know. Still really confused why this doesn't work. Oh, wow. I don't even have the update before tag. You know what? I'm gonna take that update before tag off. I'm gonna turn this back on because this job system now is calling complete on these jobs. So it's waiting on the thread to be done with these already. I'm just curious if that will fix our weird bug that I cannot. What is its deal? Nope. There it is. It's still there. All right. I'm going to put this tag on. I don't think that this is going to fix it, but I'm going to find out. No. Oh, you know what? I had the tag on this thing too. forgot about that. I'm going to take both of those tags off. I guess I don't know what it means if you're using a barrier system already to put that tag on there. If the tag's on the barrier system. If this works. Nope. Okay. So it doesn't really seem to have anything to do with this. And I'm just going to put both of these on the tags just for good measure. So yeah, I have no idea. It was working earlier. And it was only working when I would schedule these. And it was scheduled to be after that. What happens if I change this into update after? Update after. What does that do? Yeah, that does not help anything. Okay. Yeah. No help. Something about this really doesn't like it. Which I don't understand, but that's fine. But what we did do is take the space membership outside of the physics system itself. We put it in its own system. It is also now jobified. Oops. This isn't working right now. That's gone. I honestly don't know why putting those in the same system made any difference. But it seems to make a difference. Seems to make a very big difference. This is actually a pretty empty class right now. Considering that we can't, for whatever reason, get this to work. Yeah, and these post-update commands didn't really help either. Interesting. So I'm going to get rid of our space membership system since we have this better space membership job system. It's like a micromanagement or a micro optimization, but hey, it's a little bit better, and we're building out a physics system. Every time. Oh boy. That's the Unity error I can't get out of. But every time we make a little micromanagement or micro optimization, that is actually a big deal in a physics system as opposed to just like, your basic old whatever you're writing, web page or whatever. So I think that's all I have for today. Hopefully next time we'll come back and we'll look at whatever the next step of space is. Let's just look at it right now. Space.cs. Keep going. Okay. Entity state write buffer. We're going to look at that. How that works. Maybe I'll have it written already. Maybe I'll write it here. Either way, hope to see you next time. And I'm out of here.